How would you evaluate sine of pi over 2 plus pi over 6? What about sine of pi over 4 minus pi over 6? And what about these other two questions? All of these questions require the use of the trigonometric angle sum and angle subtraction identities. But these identities are extremely difficult to memorize, and to be able to use them effectively on a test, you must know how to derive them. So let's go to that. The angle sum formula can be derived using the following diagram. We can begin by finding the length of ED. Sine of B is equal to ED over 1, which is just ED. So we can label ED as sine of B. Similarly, AE is just equal to the cosine of B, because the cosine of B is just AE divided by 1. Now we can turn to triangle ECD. Tangent of angle alpha is equal to opposite over adjacent, which is just ED divided by EC, which is sine of B divided by EC. So we can get that EC is equal to sine of beta divided by tangent of angle alpha. Now we can do some angle chasing. So angle ADE is just 180 minus beta minus 90, because 90 is the measure of angle AED. So angle ADE is just 90 minus beta. Similarly, angle EDC is just 90 minus alpha. So we can use this to get angle ADB. Angle ADB is equal to 180 minus angle ADE minus angle EDC, which is just 180 minus 90 minus beta minus 90 minus alpha, which is beta plus alpha. So we get that angle ADB is just angle alpha plus angle beta. So we can use the same trick that we used at the beginning to find the measure of AB, which is just the sine of ADB, or the sine of angle alpha plus angle beta, the measure of those two angles. The last triangle that we need to use is triangle ABC. The sine of angle alpha, the sine of alpha is equal to AB over AC. AC. And we know the length of AB, and we can find the length of AC by adding AE and EC. and AC is just cosine of angle B plus sine of angle B divided by tangent of A. Cosine of angle B plus sine of angle B divided by tangent of angle A. So we can actually use this to solve for sine of A plus B. We can begin by multiplying both sides by cosine of beta plus sine of beta divided by tangent of alpha. And we're using this and this as the sides of the equation. And I'm going to rewrite tangent of alpha as sine of alpha divided by cosine of alpha. And then we can multiply both sides of this fraction by cosine of alpha. Finally, we can distribute the right-hand side of the equation to obtain our identity for the angle sum of sine. And these two cancel when you multiply these. And this is our sum identity for sine. Alright, so we can use the sum angle formula to solve the first problem out of the 4 problems I showed. But how do we solve the second problem? Well, this is actually much easier than it was to prove this first identity. What we can do is just plug in. Well, we can use the fact that sine is an odd function, which means that if we have an angle x, you have that sine of minus x is equal to minus sine of x. So we can just, if we want sine of alpha minus beta, just write this as sine of alpha plus minus beta. So this is just equal to sine of alpha times cosine of minus beta, and adding on to sine of minus beta times cosine of alpha. So cosine of any negative angle is just equal to the positive version of that angle. So we can rewrite this as sine of alpha times cosine of beta, and then we're just moving this minus sign outside, so that'll become minus sine of beta times cosine of alpha. And once again, you don't have to memorize this identity because this is easily derived from this first identity. So if you were going to memorize any identity, it'd probably be this one. To prove the cosine angle sum and angle subtraction identities, we are going to be using this identity right here, which says that cosine of any angle x is equal to sine of 90 minus that angle. So let's try to find cosine of alpha plus beta. This is equal to sine of 90 minus alpha plus beta, which is sine of 90 minus alpha minus beta. We can use the angle subtraction formula for sine to solve this. So we rewrite this as difference of two angles, which is an angle 90 minus the angle alpha minus the angle beta. So this is just equal to sine of 90 minus alpha times cosine of beta, and then minus sine of beta times running out of space here, cosine of 90 minus alpha. So we can use this identity here again to simplify this expression. We can just rewrite this first term as cosine and this last term as sine. So that would be cosine of alpha times cosine of beta minus sine of beta times cosine of sine of alpha. And we can just reorder these terms. And this is our angle sum formula for cosine. We can use the same strategy that we used for the sine subtraction formula to find the cosine subtraction formula. So we can rewrite cosine of alpha minus beta as cosine of alpha plus minus beta. So this is just equal to cosine of alpha times cosine of minus beta minus sine of alpha times sine of minus beta. Cosine stays the same when the angle is negative, but once again, sine is an odd function, so sine of minus b becomes minus sine of b. And these two negative signs make it positive. So we have cosine of alpha times cosine of beta plus sine of alpha times sine of beta. It's time to tackle the tangent, angle sum, and angle subtraction formulas. So since tangent of any angle is just sine of that angle divided by cosine of that angle, we can write tangent of alpha plus beta as sine of alpha plus beta divided by the cosine of alpha plus beta. And then we can just use our angle sum identities for both sine and cosine. This becomes sine of alpha times cosine of beta plus sine of beta times cosine of alpha divided by cosine of alpha times cosine of beta minus sine of alpha times sine of beta. Now, if you're clever enough here, then you can realize that if you divide both sides of this fraction by cosine of alpha times cosine of beta, then you can achieve the tangent addition angle formula. But that might be a bit hard to see if you aren't too experienced. So we can do this by writing sine of alpha as tangent of alpha times cosine of alpha, since we're just multiplying the the definition of tangent by cosine on both sides. And similarly, we have that sine of beta is equal to tangent of beta times cosine of beta. So we can just plug these in. You have tangent of alpha times cosine of alpha and times cosine of beta plus tangent of beta times cosine of beta times cosine of alpha and cosine of alpha times cosine of beta minus tangent of alpha times cosine of alpha times tangent of beta times cosine of beta. Okay, so now we can see that there's a common cosine of alpha and cosine of beta in every single term in this fraction. So we just divide both sides by cosine of alpha and cosine of beta. And we get tan of alpha plus tan of beta is 1 minus the tangent of alpha times the tangent of beta. And this is our sum angle formula for tangent. We can repeat a similar process for tangent of alpha minus beta. So we would just rewrite tangent of alpha minus beta as sine of alpha minus beta times cosine of alpha minus beta, which is sine of alpha times cosine of beta minus sine of beta times cosine of alpha divided by cosine of alpha times cosine of beta plus sine of alpha times sine of beta. Now I'm just going to show you the trick that I was talking about earlier. So we're just going to divide both sides by cosine of alpha and cosine of beta. So in the first term here, cosine of beta would cancel out, but we would be dividing by cosine of alpha. So that would be sine of alpha divided by cosine of alpha. And similarly here, this cosine of alpha cancels out. So we get sine of beta divided by cosine of beta. on the bottom, we have that both of these cosines cancel out here, so we're just left with 1, and we have sine of alpha times sine of beta divided by cosine of alpha times cosine of beta. So we actually notice here that each of these terms can be simplified using the tangent definition. So this is just tangent of alpha. This is just tangent of beta. And the bottom here is just tangent of alpha times tangent of beta. And these are our sum and subtraction angle formulas for tangent. Now, let's go back to the questions that I showed at the beginning to see examples of the applications of these formulas. So before you go ahead and plug in any of these numbers, I'd recommend that you first check to make sure that the sum isn't anything that you can evaluate immediately using the unit circle. So power 2 plus pi over 6 can be rewritten as 3 pi over 6 plus pi over 6, which is 4 pi over 6, or 2 pi over 3. And indeed, this is actually something that you can evaluate using the unit circle. So when I try to evaluate these types of expressions, or in this case, sine of 2 pi over 3, I don't memorize the numbers in the unit circle. I actually refer back to the unit circle and try to picture it in my head. So this would be closer to the this would be closer to the y-axis than it is to the x-axis. And I know that this angle is a multiple of pi over 6, which means that the lengths are the ratios of the side lengths for sine and cosine of a 30, 60, 90 triangle. So for sine, this would be just root 3 over 2. Alright, let's evaluate sine of pi over 4 minus pi over 6. So we can plug this into our angle subtraction formulas. So this is sine of pi over 4 times cosine of pi over 6 minus sine of pi over 4 times cosine of sine of pi over 6 times cosine of pi over 4. Sine of pi over 4 is actually right in the middle, so I've memorized this as root 2 over 2. So we have root 2 over 2 times cosine of pi over 6, which is closer to the x-axis than it is to the y-axis. So this for cosine would be root 3 over 2. And we're subtracting sine of pi over 6, which would be 1/2 times cosine of pi over 4, which is root 2 over 2. And we can just expand this. This is root 6 over 2 minus root 2 over 4, root 6 over 4. So since these share a common denominator, we can just rewrite this as root 6 minus root 2 over 4. And that is our final answer. Before we move on to the next couple of problems, keep in mind that a lot of the times the questions aren't going to be directly giving you the breakdown of these two angles. So for this, it would be actually, the test would probably show cosine of 5 pi divided by 12. And you'd have to be able to see how to break this down into unit circle numbers that you can use. So we can just rewrite this as cosine of power 4 times cosine of power 6 minus sine of power 4 times sine of power 6. By the way, if you work through all of these methods to derive the identities, I think it is quite likely that you will be able to memorize these formulas automatically without even just going into a textbook and just trying to memorize them. So cosine of power 4 is root 2 over 2, and cosine of power 6 is root 3 over 2. Sine of power 4 is root 2 over 2, and multiplying this by 1/2. So this root 6 over 2 minus root 2 over 4. Oh, sorry, this is 4. And this is just root 6, 2 minus 4. So another way that we could have gotten this is if we used the previous problem, because we know that 90 minus any angle is just for like sine of 90 minus any angle is just equal to cosine of that angle. And these two angles add up to make 90 degrees, which is power 2. So we would know that these two values here, this one and this one, are the same. Alright, lastly, let's go to tan of power 3 minus power 4. Using the tangent angle subtraction formula, we get tangent of power 3 minus tangent of power 4 by 1 plus tangent of power 3 times tangent of power 4. I don't have any values of tangent memorized other than power 4 because sine and cosine are the same for this value. So now let's take a look at unit circle. So power 3 is closer to the y-axis than it is to the x-axis. So I know that cosine is smaller. And using the 30, 60, 90 triangle ratios, I know that, well, let's first rewrite tangent of power 3 as sine of power 3 and cosine of power 3. So I know that, using unit circle, I know that cosine is smaller, so cosine would be 1/2, and sine would be root 3 over 2. So this is just root 3. Go back to our fraction up here. We can plug these values in, and we get root 3 minus 1 divided by 1 plus root 3 times 1, which is root 3 minus 1 times 1 plus root 3. Now, let's just rationalize the denominator. So, root 3 minus 1 times root 3 plus 1. We can multiply both sides by root 3 minus 1 without changing the value of the fraction, because root 3 minus 1 divided by root 3 minus 1 is the same, it's just 1. So, and multiplying anything by 1 keeps the value the same. So this is 3 times 3 minus 2 root 3 plus 1, and the bottom here is 3 minus 1. So this is 4 minus 2 root 3 divided by 2, which is 2 minus root 3. And that is our final value.